July 2026 arrived during a period of intense technical anxiety. Every few weeks, another model seemed to conquer a new human benchmark, from high-level mathematics to complex legal reasoning. Then, developer Eric Liu released a video showcasing something called the Ghost Font. It went viral overnight, hitting 17 million views as people shared what looked like a breakthrough. The promise was simple: a message human eyes could read instantly, but which blinded every major AI model on the planet. For one single day, the internet celebrated. It looked like humans had finally found a cognitive task that machines simply couldn't replicate. But the Ghost Font wouldn't remain unreadable for long. The speed and the font itself. The Ghost Font works by converting typed characters into a specific kind of video. The pixels forming the letters slide upward, while the background noise slides downward. You read this through a biological principle called common fate. Your brain automatically groups objects moving in the same direction, seeing a unified shape. But AI models struggle because they don't perceive motion. They process video by breaking it into individual static frames. While your visual cortex solves the puzzle in 0.1 seconds, the AI is left looking at thousands of frames of static snow, unable to find a single legible character. It was a clever exploitation of a hardware difference, millions of years of evolution outperforming digital architecture. To make the trap even more effective, Eric added a second layer, a hidden decoy message embedded directly in the code. It stops its analysis and reports successful decryption. The results were immediate. ChatGPT 5.5 Pro spent 19 minutes attempting to process the file before eventually hallucinating a message that didn't exist. Gemini 3.1 Pro fell for the trap entirely. It read the decoy code and earnestly informed the user that the hidden message was "send nudes." Because the entire process ran locally in the browser, the system appeared to be a reliable way to hide information in plain sight of the models. That sense of security lasted less than 24 hours. The bypass didn't require a new model or a massive breakthrough in computer vision. It was accomplished with a single instructional prompt given to GPT 5.6. By telling the AI to stop looking at the frames as images and instead write a script to calculate pixel velocity, the model was able to reconstruct the text perfectly. This demonstrates how fragile human-engineered limitations can be. When the logic shifts, the limitation often disappears. The story of the Ghost Font fits into a much larger historical cycle. We identify a human skill that machines can't touch, only to watch that gap close. In 1997, it was chess. Deep Blue's victory over Garry Kasparov marked the end of the idea that strategic intuition was a purely human domain. In 2016, the game of Go fell to AlphaGo, proving that machines could master patterns that even the best human players struggle to articulate. This chart tracks the interval between humans identifying an AI weakness and the AI overcoming it. The time it takes for these barriers to fall is dropping from years to hours. If AI limitations are temporary engineering hurdles rather than permanent laws, our focus shifts. The goal is no longer to find ways to beat the models, but to find ways to build with them. In July 2026, a developer named Eric Liu released an experiment called the Ghost Font. It reached 17 million views overnight because it promised something no other security measure could: a way to communicate completely invisible to artificial intelligence. The Ghost Font works by generating a video of moving pixels. The characters of your message slide in one direction, while the background noise slides in the other. This diagram illustrates why humans can read it instantly. It's a principle called Gestalt common fate. When a group of random points moves in the same direction at the same speed, our brains automatically perceive them as a single unified object. This defense is built on millions of years of evolutionary hardware, motion perception originally tuned to spot a predator moving through tall grass. Our visual cortex separates the signal from the noise in a fraction of a second. Modern multimodal AI lacks this biological advantage. These systems are essentially image models wrapped in a video shell. They process video by slicing it into individual static frames. Without motion, each frame looks like meaningless snow. To make the failure complete, the font includes a second layer of protection, a hidden decoy message designed specifically for machines. When tested, the most powerful models on the planet failed. GPT-5.6 spent 20 minutes attempting to decode the file before hallucinating a non-existent answer. Gemini 3.1 Pro found the decoy, confidently reporting successful decryption and completely missing the actual message. This combination of biological motion perception and a clever digital trap gave us a sense of absolute victory. For a brief moment, we had found a wall the machines couldn't climb. But that victory lasted for exactly 24 hours. Less than a day after the ghost font reached its viral peak, the supposedly impenetrable wall collapsed. The defeat didn't require a massive code update or a new generation of hardware. A user simply gave the existing AI a single sentence of instruction, telling it how to analyze the pixel motion within the frames. In an instant, an AI that was blind to the font became completely fluent. It successfully bypassed millions of years of human evolution because someone figured out the right way to ask it to look. This follows a familiar rhythm. We have seen a dozen impossible barriers, from the ability to create art to the understanding of complex context, becoming standard features in a matter of months. The ghost font represents a new, faster reality. The time we have to celebrate a unique human advantage has shrunk from years to a single day. We are caught in a cycle. We find a biological quirk the AI can't replicate, we declare it a permanent limit of the technology, and then we engineer a way past it. In the 90s, we believed the strategic complexity of chess was a sanctuary for human intelligence. Deep Blue ended that era in 1997. We then moved the goalposts to intuition, claiming the game of Go was too abstract for a machine to ever grasp. That belief stood until AlphaGo defeated Lee Sedol in 2016, a moment of visible shock for the entire world. The pace is accelerating. AI is now solving math problems that have stumped humans for 50 years and predicting protein structures in a fraction of the time it takes traditional laboratories. This graph shows the collapse of that human-to-AI gap. What used to take decades for machines to conquer now happens in hours. The ghost font is the latest point on a curve that is crashing towards zero. We have to accept that our current technical limitations are not permanent biological boundaries. They are merely engineering speed bumps. Because the window between an AI failing and succeeding is closing so rapidly, building traps to fool these models is a losing game. This means we cannot base long-term strategies on the assumption that AI flaws are permanent. If your value is based on something AI can't do today, your value has an expiration date that is likely much sooner than you think. Mastery now lies in communication. A single, well-placed instruction cracked the ghost font more effectively than any new hardware or model update. Learning to craft those instructions is the most important skill in this new landscape. Future value will come from orchestrating systems that use AI for its raw power, while using human insight to guide it through its temporary weaknesses. This week, find a task you are certain an AI cannot do and try to prove yourself wrong. The 24-hour victory of the ghost font shows us that we can no longer rely on walls. We have to learn how to use the tools that are tearing them down.